Okay, and welcome back. Delighted to be joined by friend and colleague, actually, Tanja Braun from Fraunhofer Institute.
Okay.
Nice to see you, Tanja.
Yeah, thank you.
Yeah, so maybe you can tell us a little bit about some of the work that you're doing at the moment at the Institute. You're basically the manager of the advanced packaging integration area. What's going on?
Yeah, so as an institute, we're doing advanced packaging, and I think technology-wise, we're doing a lot of embedding, and we'll be studying heterogeneous integration also for these embedding, but also for chiplet approaches and antenna integration and all these topics.
Right. Okay. There's a lot of different technologies going on there, but a lot of this is surrounding the work you're doing for 5G and boards like this. Is this the areas that you're working in?
Yeah, I think there is a lot of developments, innovation in millimeter wave RF packaging with new materials, but also new packaging concepts with passive integration and also 3.5 semiconductors mixed with silicon germanium. There's really a lot of new things ongoing.
Right. Okay. Talking about the heterogeneous integration, I mean, that's an area where you're trying to get all the materials within the package to be compatible, essentially. How do you make that work? Because a manufacturer of materials knows well how his materials interact with his own underfills and encapsulants, but not necessarily with other people's.
Yeah.
Can you explain to me how that works?
That is the R&D development work we really have to do, and I think it's also that we see a lot of new materials because we also see different applications, has new demands. Again, low loss materials for all these millimeter wave packaging, but we really have to fulfill different demands. So if you have 3.5 semiconductors and we have maybe gold as an interface, which has to stick to the encapsulants, to adhesives, that is different as if you have silicon. So that is really what we have to bring together and really optimize, select materials, maybe also discuss with material suppliers.
Right.
Yeah.
So there's a lot of work involved in that, that's for sure. Yeah. Great. You've also been, thankfully, been working with us on the committee for the low temperature soldering conference, of course. And that's a growing area, and there's people using low temperature solders for different reasons. What is your view on that market?
We're also using that because it is an option also to have, especially for system and package, when we have different solder levels or assembly levels where we have to stack components, and then that could help that you have lower melting solder in that different hierarchies. And of course, we have colleagues who are looking more into the energy saving green electronics. That might be definitely also an advantage.
Yeah.
But I think there's still a lot of R&D to do to better understand these systems, also in combination with surfaces, but maybe also in interaction with standard tin silver copper solders, for example. Maybe sometimes we even did that combination because we got area array components which already had solder balls and these things.
Right. Yeah. I mean, there's a lot to unpack there and get to understand. But as you say, the sustainability is driving people to want to use less energy. And it also increases the reliability of the electronics, of course.
And there's also a lot of discussions and also on the repair and reuse of electronics ongoing. That might be also interesting to have lower melting solders also for repair and maybe exchanging components for reuse of mobiles, but also of tablets and things like that.
Right. I mean, one of the issues I find that it might be a thing for LTS is the fact that most of your grid array products are using standard SAC 305 in the balls and which obviously reflow at a much higher temperature than the low temperature solders. So is that potentially an issue?
Honestly, we still don't know. We have done that because we had no other way to build samples in that way, but we have looked a bit into it, and it's a quite complex solder structure, especially depending on maybe the later temperature you still apply after soldering, and yeah, if we do the components by ourselves and the balling, then of course we can already choose also low melting temperature solder balls, and of course that is maybe one strategy and not. But
Right.
if you have to buy components from the markets, I think typically you don't have a choice. So.
Right. Okay. Well, it's always good to sort of catch up with you and find out what's going on at Fraunhofer. And I want to thank you for all the help you've given us on LTS and coming in today. Okay.
Okay. Thank you very much for being.
Thank you. Okay.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.